secured.
Okay, let's take her down. Privateer Illuminat. My vent's open. Time 0935. Over.
Aluminaut, privateer. Roger. Vents opened at 0935.
Come right to 180, George. Go ahead 2/3, 10-degree down angle.
Oh, head 2/3. Coming right to 180. 10-degree down angle.
Privateer Illuminat, steering course 180. Going ahead 2/3 speed. Over.
Illuminaut, privateer. Roger. Course 180. Ahead 2/3. Your decks are awash. Your vertical motor is awash. Your sail is under.
Voyage to the bottom of the sea. Part of the conquest of the deep ocean. How has this come to pass? Where did it all begin? Man's curiosity about the oceans is more ancient than history itself. But the first vehicle to carry man into the depths wasn't available until modern times. William Beebe's bathysphere, a ball of heavy steel with portholes of thick quartz, carried Beebe and a companion to a record depth of 3,028 feet in 1934. The next step came in the 1950s with Jaccques Piccard's bathyscaphe, Trieste, the first true boat of the deep. The cigar-shaped body was filled with gasoline to give positive buoyancy, while the crew rode a steel sphere beneath, making Trieste, in effect, an underwater balloon. Purchased and operated by the Navy, she reached the deepest known part of the ocean, diving 35,800 feet into the Mariana Trench. Other underwater vehicles were developed by the 1960s. The Cousteau diving saucer went to about 1,000 feet. The Perry Cubmarine dives to about the same depth. Another group of submersibles was developed for intermediate depths. Alvin, designed by the Office of Naval Research and operated by the Woods Hole Oceanographic Institution, goes to 6,000 feet. Deep Star, built by Westinghouse, reaches 4,000 feet. Deep Quest, a Lockheed Aircraft Corporation submersible, dives to 8,000 feet. Illuminat, belonging to Reynolds Submarine Services, can reach 15,000 feet. Still the deepest diver of all is the bathyscaphe. Trieste II, a new version, was built by the Navy. Grumman Aerospace Corporation's Benjamin Franklin is a medium-depth diver, but with the special capability of prolonged submersion. She stayed underwater for 30 days while drifting with the Gulf Stream from Florida to Nova Scotia. Most extraordinary of all is the Navy's nuclear-powered NR-1, specially designed and equipped for detailed studies and mapping of the ocean floor, and able to remain submerged for long periods of time. Another specialized vehicle on stage is the DSSV, the Deep Submergence Search Vehicle, with a 20,000-foot capability for search and salvage. All of these deep submersibles are smaller than military submarines, but there's another, more profound difference. Like Jules Verne's imaginary Nautilus, the research and salvage submersibles are designed to let men see the ocean bottom. They have viewports, and they have lights to illuminate the one-time mysteries of the deep. Is there vegetation? What's the bottom like? Are there fish or other forms of life? The human eye, compensating automatically for dimness, for poor contrast, for changes in range and color, can tell the brain directly what lies out there. Now, man can gain new knowledge by direct observation of the depths. deep submersible allows the oceanographer to study plant life down to the practical limits of photosynthesis at about 1,800 feet. Animal life, of course, is found much deeper. All the depths are now a laboratory for the marine biologist. The scientist finds new forms, forms only suspected before from broken bits of substance clinging to deep trawled nets. The scientist learns facts, too, about familiar sea animals, finding sharks, for example, as deep as 4,000 feet. The geologist also becomes an oceanographer, studying underwater topography from deep canyons to areas of flat ocean floor. Deepwater currents are studied, here by setting up a three-dimensional grid with nylon streamers attached and leaving an automatic camera to film the streamer movements. Across the ocean bottoms today, deep submersibles are mapping, surveying, letting oceanographers see and study the features they knew before from instruments alone. A whole world of underwater engineering is opening up. Underwater cables are checked and serviced. Underwater tracking ranges are inspected. Underwater oil fields are explored. And soon, those fields will be tapped and serviced by deep submersibles. Search and salvage operations get most of the headlines. It was big news when Trieste II found and positively identified the submarine thresher from this bit of piping found at 8,400 feet. It was big news, too, when Alvin found the H-bomb in 2,750 feet of water off Spain by following skid marks down a slope. When Alvin had to surface, Illuminat homed in on Alvin by sonar, communicated, and watched over the bomb. The first underwater rendezvous of deep divers. Deep sea salvage, just one phase of ocean exploration. Suddenly, we have the tools to probe the depths. But what of the techniques? What of the hazards we must overcome?
Starboard ahead 1/3, come left 30 degrees.
Starboard ahead 1/3. Coming left 30 degrees.
Bob, drop 100 pounds a shot, lift up and go ahead on course 170. Run 5 feet off the bottom.
Roger. Go ahead, George, come to right, 170. £100 out.
On course 170, altitude 5 feet, make the maximum 2/3 turn.
Roger.
Have a sonar contact. It's 20 degrees on the port bow. Range is 300 yards. Sonar contact appears to be a large cliff.
Roger, cliff at 300 yards. Continue on course and close the cliff until I pick it up visually. Over. I have the cliff in sight now. Come right 30 degrees. Run parallel to the cliff about 30 yards off. Over.
Roger.
All right, come right to 140, George.
Roger, 140.
Have the cliff on the port side, 30 yards, and we're running parallel on course 140.
Starboard stop, port ahead 1/3.
Starboard stop, port ahead 1/3.
The undersea pilot encounters a variety of hazards, some of them man-made, but most of them natural. Currents pose numerous problems. While most deep ocean currents average 1/5 of a knot or less, their speed may increase to over 3 knots where topography is rough, a dangerous condition, since most deep submersibles cruise at only 1 or 2 knots. The turbulent flow is a rare phenomenon, like an avalanche. The movements of the submersible itself may also stir up the bottom, or sediment clouds may be set up by currents. The undersea pilot tries to move into the currents, leaving the sediment behind and also gaining maneuverability. Overhangs can be particularly perilous. A submersible coming up under one could be in real trouble. Large sea animals can be a nuisance. The natural hazards can usually be anticipated, but the man-made ones are often a surprise. The submersible sent to inspect underwater cables may well get tangled with them. They must be approached into any current and with extreme caution. Underwater wrecks are tempting. There's a natural tendency to investigate, but wrecks have protruding parts and rigging that could damage or trap a submersible. Unless they're part of his assigned mission, the pilot must avoid all wrecks, while reporting and charting them, of course. Abandoned ship's gear dots the ocean bottoms. Bottom-mounted hardware awaits the unwary. One of the greatest dangers is the millions of tons of explosive ordnance left over from old wars, often completely forgotten. Explosive devices dating from as far back as the American Civil War have been found on the bottom. Most of these old-style mines and torpedoes would no longer fire, but no submersible pilot wants to gamble on that. Surface traffic must be avoided when ascending. Most dangerous of all, perhaps, can be the sea state when surfacing. Man-made or natural, any unusual object must be avoided.
Up full on the vertical motor. Take a 7-degree up angle, come up 10 feet off bottom.
Up full on vertical, 7-degree up bubble, 10-foot altitude. Roger, we passed a large rock.
Today's deep submersible is indeed a weird and wonderful craft. But only a crew of able, dedicated men can take her down and make her do her job. It's all the pilot's responsibility. He must be able to take his craft to the limits of her design, whatever the type of submersible. A pilot may be called on to handle a small, shallow diving vehicle like the Perry Cubmarine, the Navy's deep diving bathyscaphe, Trieste II, or a long-duration, medium-level vehicle like Benjamin Franklin. The Reynolds Aluminaut offers the pilot most of the challenges and problems he would face in any deep submersible. Her 50-foot hull, 8 feet in diameter, is spacious enough for an operating crew of 4, and also usually carries 3 scientists or technical observers, plus up to 6,000 pounds of specialized instrumentation.
Okay, 800-yard range, wide band.
Illuminat can operate as deep as 15,000 feet, descending slowly to the bottom under the weight of water ballast and steel shot, then dropping enough ballast to achieve neutral buoyancy. After bottom operations, she discharges more ballast to surface, even dropping 4,000 pounds of lead from her keel in an emergency. Illuminat's size and versatility, with her ability to carry large loads of specialized equipment, make her valuable for both ocean research and deep-water salvage. The pilot must learn every aspect of his submersible's operation. First, he must rig her for sea. He must know how to handle her on the surface and while under tow. A submersible as large as Illuminat may be towed many hundreds of miles, often in heavy seas. For longer distances, she can be transported by large ships, either on deck or in the wells of vessels like Navy LSDs. In any case, getting to the site, plus launching and recovery, may be far more difficult and even more dangerous than underwater operations. The submersible's manipulator arms are capable of many intricate operations, from picking up objects on the bottom to manipulation of tools and drilling for bottom samples. Cameras and strobe lights are also operated from forward control. The pilot mans the forward control station during bottom operations. While the pilot is forward, the central control station is manned by a controller man and the co-pilot. The co-pilot supervises, but most controls are actually handled at the controller man's position, which is filled by either of the other two crewmen, the electrician or the electronics technician. The men at central control can watch underwater operations on closed-circuit television. They also have a sonar screen and an underwater telephone.
Privateer Illuminat passing 4,000 feet, over.
The fathometer can be operated in two modes, giving either the distance above the bottom or the distance beneath the surface. One depth meter covers the submersible's entire range. Another can be set at the operating depth and will then show the smallest movements up or down. The crew member serving as controller man handles the three motors, port, starboard, and vertical. He steers by varying speed on the port and starboard motors and by using the rudder. There are several methods of controlling depth. Diving planes, which will angle the submersible up or down, a trim pump, which adjusts trim by pumping water ballast back and forth between bow and stern, and switches to drop shot ballast, discharge or take on water ballast, and in a dire emergency, drop the lead bar from the keel.
All stop.
There's the target.
The pilot directs all operations, moving between control stations to suit the circumstances.
Oh, good one,
Privateer Illuminat, we have a target dead ahead, 650 yards, over. Okay, lift up and let's go ahead.
When buoyancy is neutral, the submersible can be moved up or down about 1,000 feet by trimming the diving planes and adjusting water ballast. Then driving ahead with the horizontal motors and up or down with the vertical motor. The controller man's job can be a tiring one, and in a long dive, the crew members will alternate.
Take it a while, George. Steering 180, maximum 230, both motors.
180. I appreciate it. Give me a cup of coffee, will you, George?
The central control station is like a ship's bridge. There is always one man at the helm and another to supervise, either the pilot or co-pilot. Ocean exploration requires not only submersibles that are marvels of engineering, but men, pilot and crew, whose high skills determine the success or failure of a mission. Illuminat has been assigned to retrieve an experimental torpedo, and she is now approaching the bottom.
Okay, Bob, take over here. I'm going to go up and rig forward control.
All right.
The pilot directs bottoming operations from forward control. The outside lights allow him to check the descent rate visually. There's always enough life or particles in the water to show upward or downward movement of the submersible. Instrument readings on depth and descent are fed constantly to the pilot from central control.
350 feet to bottom.
Roger, 350 feet to bottom. Bob, get me a descent rate.
Roger. Descent rate is 40 feet per minute.
Roger. Up full on the vertical motor. Drop 200 pounds of shot.
Roger.
Up full on vertical.
200 out.
Roger. Altitude.
Altitude is 150 feet. Descent rate is 30 feet per minute.
Roger. Altitude.
Altitude 100 feet.
Roger.
I have bottom in sight, 50 feet. Drop another 100 pounds of shot.
Roger. £100 out.
Privateer Illuminat, 50 feet to bottom.
50 feet, aye.
30 feet to bottom.
30 feet, aye.
10 feet to bottom.
10 feet, aye.
On the bottom, all stop.
All stop.
Privateer Illuminat on the bottom. Privateer Illuminat, we're on a fairly smooth but gradually sloping bottom. Current direction appears to be from the east. Over.
Illuminat Privateer, roger. Target should bear 165 true from your position. Range about 250 yards. Over.
Roger, Privateer. Target 165 true, 250 yards. Go ahead 2/3, come left to 165.
All head 2/3. Come left to course 165.
Target 200 yards, dead ahead.
Roger, continue at 2/3 speed, close the target. Privateer Illuminat, we have the target on sonar, 200 yards dead ahead. We're closing it now. Over.
Target dead ahead, 150 yards. Sonar contact dead ahead, 75 yards.
Roger, slow to 1/3.
Slow to 1/3, aye.
Contact dead ahead, 30 yards.
I have the target in sight, 50 feet dead ahead. All stop, shift control forward.
All stop. Shift control forward. You have control forward.
Privateer, I have the target dead ahead of me now, 50 feet. I'm closing it. Over.
Roger, Illuminat. Target 50 feet and closing.
George, take control of the motors. All back full.
Got control of the motors, all back full. Backing full.
All stop. Privateer, we have the unit securely on the hook now. Are we clear to surface? Over.
Illuminat, privateer. Affirmative. You are clear to surface.
Bob, drop 1,000 pounds of shot.
Roger. £1,000 out. "30 feet off the bottom by fathometer."
Roger, 1,000 out, 30 feet off the bottom. Drop all shot and take her up.
Roger, drop all shot.
A difficult mission completed. A tribute to the advanced development of the submersible and to the skill of pilot and crew as they confidently maneuver their undersea vehicle through this hostile domain.
Fathom to indicate the weight in the bottom.
Okay, good. Well, I'm glad that's over. We got it on the hook. Privateer, Illuminat, we've dropped all shot. 200 feet off the bottom now, coming up. Over.
What once was an impossible dream is now a reality, leading man to the discovery of a whole new world beneath the sea.